Well, thank you so much for the introduction, Adam. As always, it's a pleasure to be here today at another Wood Solutions event. Welcome, everyone. During this presentation, as Adam was mentioning, I'll be talking about the use of BIM in coordination and how we can leverage the power of virtual design and construction technologies for mass timber construction. But first, I want to briefly introduce myself. As Adam mentioned, my name is Maria, and I'm a licensed architect in Uruguay. Over the past 10 years, I've been working in the global AEC industry, not only as an architect, but also as a mass timber expert and researcher. More recently, I've been working as a senior project manager at Viatechnic, where I've been working very closely with real estate developers, with architects, general contractors, subcontractors from different parts of the US in all aspects related to the phases of virtual design and construction technology adoption, in particular related to prefabricated buildings and mass timber consulting. But what is Viatechnic and what do we do? Well, Viatechnic is a technology solutions firm that is trying to transform the way that the industry works, making processes more efficient through the use of strategic through the use of strategic innovations in technology such as BIM, VR, AR, computational design, data analytics, and photogrammetry, just to name a few. We currently have 10 offices here in the US and abroad, with over 190 architects, engineers, construction managers, BIM specialists, game designers, and even software developers. Big and small, our clients are very varied, from owners to architecture and engineering firms, general contractors, and subcontractors even. But what is Viatechnic so focused on technology? Well, because we understand that digitalization is disrupting the construction industry. So let's take a look at some of the forces really driving this disruption and how that relates to mass timber. One of the forces, of course, is that is driving this disruption is the soaring world population. It is expected that by 2050, the world population will rise from 7.5 billion that is today to almost 10 billion people. And our role as AEC professionals around the world is to try to find ways to build for this growing population in a timely manner. There are also industry forces driving this disruption. As all of you know, the construction industry is a $1 trillion industry. There is a lot at stake, but the sector is currently facing two major issues. The first issue is poor productivity. The construction industry productivity has only increased 1% over the last 20 years. And when we compare it to other industries, such as the manufacturing industry that have increased their productivity exponentially, there is some work that needs to be done. The second issue is a workforce shortage, so much so that 80% of construction companies in the US are having issues finding workers that they need for their jobs. The last force that is driving this disruption is, of course, climate change. As all of you are aware, the construction of buildings across the world is dominated by the use of concrete and steel. But the manufacture of cement, it's one of the most polluting processes, producing 1 ton of CO2 for every ton of cement. And globally, buildings generate nearly 40% of all CO2 emissions. So it's really important to find ways to start reducing our reliance on cement. So how has the industry responded to these challenges? Well, that brings us to the resurgence of wood in construction and the development of mass timber systems, which have allowed us to really build more efficiently, faster, and sustainably for future generations. And of course, in the US and around the world, the use of mass timber and mass timber products is really not new. Mass timber structures have been built around the world for more than 100 years. And an example of this is the Butler Building in Minneapolis, Minnesota, which was built in 1908 and is to this day used as an office building in the downtown area. Of course, the benefits of wood and mass timber in general have been well studied for over 20 years. And I won't get into details about that today because it's not the topic of this presentation. However, I do think it's important to note that the speed of construction, which can be approximately 20-25% faster than concrete, according to several studies and manufacturers' experience, it's a clear indication that the use of this type of system could be suitable as an answer to the worker shortage that the construction industry is currently facing. At the same time, of course, with the exponential growth in building needs, this could certainly be a great opportunity for the industry to build faster, more sustainably, and also with a shrinking workforce. So now, how can the technology that is currently available for the construction industry at large help bring these prefabricated mass timber projects to life and also help us tackle that productivity challenge that the industry is facing? Well, in part, the answer is BIM. For those of you who are not familiar, Building Information Modeling, or BIM for short, is a 3D model-based process that gives architecture, engineering, and construction professionals the insight and tools to more efficiently plan, design, construct, and even manage building. It is key to note, however, that this is a process and not a piece of software or technology. In theory, BIM is not related to any specific software or any application and can be expanded to include various workflows and tools that can really help us leverage the information and foster greater collaboration. To put this into context, a recent research has shown that the use of BIM could increase the industry productivity as much as 60%. So during the BIM process, what are we doing is basically generating a virtual twin of our building and adding data that we can then share and help us inform decisions throughout the building life cycle. Having high levels of data in a model keeps everyone on the project team on the same page, which can really help us at all stages of the project, from schematic design all the way to construction documentation and even operation and maintenance. But the process is not only part of the equation. At BioTechnic, we truly believe that the project success is a product of the people, the process, and the technology. When BioTechnic provides prefabrication and consulting services to clients, we take the time to really understand our client project needs, the desired outcomes, and really create a plan and help them walk them through that plan that really aligns the best people, the most efficient workflows, the correct technology that really help them achieve those project goals. Over this next few slides, we will cover some of those important aspects that we typically relate to mass timber buildings associated to these three categories. Now, the people portion of this approach looks into the part of the team that is engaged during the construction and the design is often as important as technology and the process we use, but sometimes get overlooked. So in a traditional design construction project, all project stakeholders join the project at different stages, right? And that means during the design, the planning, the construction of the building. And more often than not, these team members have to wait for each other's design completion, and then data gets piled in these silos before it can be exchanged between the design teams. And then that turns into decision making, taking longer due to lack of readily available information. In contrast, when we take an integrative BIM-based design approach, early and timely exchange of information between all the participants, it's enabled by sharing and integrating the building information models of different teams from day one. This allows real-time design adjustments and development, which is, I think, integrative. With this integrative approach, the information is always up to date. That is key, right? Because it facilitates communication between all of the players, including the manufacturers, and it allows for a continuum of information flow instead of having this interrupted batch flow. And this, of course, enables better information decisions early on in the design process instead of leading those decisions to later in the process. BIM also helps us in the involvement of the owner and the owner representative throughout the design process. The owner's early feedback is really valuable, as it can help us eliminate decisions and changes downstream, which could result in rework, cost, and even time wasted in most cases. And also involving the owner continuously as the design progresses adds value proposition and would be properly translated throughout the project lifecycle instead of trying to incorporate that feedback later on in the process. Even though this approach, of course, is useful for any kind of project, it is particularly important when we talk about prefabricated systems such as mass timber, where we do have panels that and other elements, not only panels, that come from the manufacturer already pre-dimensioned and with the openings and the MEP penetrations pre-cut, where all of the tolerances are very low, and therefore accuracy is key to guarantee the project success. So we need to make sure really that potential issues and conflicts are identified really early on to avoid surprises on site. So one question that I always get asked is, how early is early? And when we bring up all these stakeholders together, how early do we need to decide if we want to adopt a mass timber system? Well, the easy answer to that is as early as possible. And if possible, as early as the schematic or preliminary design phase. Early commitment to the use of mass timber by everyone on the team is super important to really successfully develop a project. Let's remember that mass timber is not simply a material substitution. It's also a system that requires a holistic approach that everyone needs to be committed to from the start. As we can see on this graph here, BIM allows us to spend more time on the critical front end and the design challenges, ensuring that we have made the best design decisions early on in the design process, instead of spending more time on documentation and trying to fix those issues later on. So this approach does require more upfront efforts. However, will allow us to really assess our design and make changes earlier on when the cost of making those changes can be less, and also it can have a greater impact in the overall cost of construction. Now, an important part of design and construction stages is what we call the BIM coordination process, during which a 3D model of the architectural, the structural, and all the MEP systems is created and reviewed with the whole team to find design and constructability issues and clashes between all the trades. In mass timber projects, system integration needs to be seamless and flawless. So it's very important to have MEP consultants and trade partners that are able to work in 3D and collaborate with the design team from day one on this integration forward. So what is the end goal of going through this whole BIM coordination process? Well, as we mentioned before, the BIM coordination process allows us to verify the design and make sure that it's constructible, right? And by developing this, an accurate digital twin, following all the specifications from the design team before we even set a foot on the construction site, we're able to see if the design can actually be built and catch potential issues before they become a problem during the construction phase. In turn, of course, we're able to reduce the occurrence, the intensity, and even the cost of change orders, of RFIs or requests for information that can have a great impact on the total cost and the time that is wasted during construction. But most importantly, coordination will allow us to develop a project that is very low risk with a high certainty, where surprises are less and less common. And in order to do that, we need to understand that risk translates into dollars. And that could be something very difficult to overcome later on during the construction phase. But before we start any type of coordination, there are some prerequisites that we need to take into consideration. Of course, the first is that we need to understand what the owner goals are and what the project goals are. And that would allow us to inform the data and the model requirements. What do I mean by that? Well, depending on the purpose and the use the owner will give to this 3D model that we're generating, is the type of information that we will need to incorporate the LOD, or level of development or level of detail of the project. And typically, prefab projects such as mass timber projects, we're looking for an LOD 400, which is a fabrication level detail. However, depending on the project and the client, that might vary in some cases. And then also knowing the project and client goals will allow us to determine and also track and measure the success in this project. Then once we got this information, we need to create a BIM execution plan. The intent of this execution plan is basically define a foundational framework to ensure the successful deployment of design technologies and workflows. The BIM execution plan is all about optimizing workflow across the project, as contrasted with this silo interest of each party. The key is good planning to minimize downstream surprises again, and rework and redundancies and gaps in the flow of information. And so there is a lot to consider when it comes to determining how information is managed, right? How is it documented? What are the standard methods and procedures that we will use to deliver this information? What are the standard cloud file platforms that we're going to use to share this information? Are we going to be using a more collaborative approach through, for example, BIM 360 design or BIM 360 docs, right? So everything needs to be included in that BIM execution plan. The BIM execution plan also needs to be a place where we agree upon roles and responsibilities, which is a strategy to make sure that everyone is on the same page and we all are able to hit the project milestones and where that fits in the wider design and construction schedule. The BIM execution plan also should detail working procedures and softwares that we will be using at different stages during the modeling and the coordination process, as well as any plugins and applications such as you might already know BIM Track or Revisto that will be used to track clashes or responsibilities. With this BIM model, you know, we need to determine who's going to manage it, who's going to maintain it, who's going to be responsible for all this. What, for example, are going to be the naming conventions that are going to be adopted? What construction tolerances are we going to be using? And what attributes are going to be required to be able to use that model later on during the maintenance and operation of the building. All of these are important questions that we need to answer with that BIM execution plan. So in summary, the BIM execution plan is basically setting up the ground rules by which we're going to be developing the building. Once we conclude this first step, the team has all the information to get started with the design and the modeling of the architectural, the structural, and all the MEP systems. During this process, the models are shared with everyone on the team and are used to inform each other's disciplines. Then comes the coordination phase, where a BIM manager or a BIM coordinator will be leading the clash detection process, often using applications such as, for example, Navisworks or associated platforms to run clash detection and find conflicts between trades and structural and architectural elements. Those conflicts are then identified, they're discussed, and then resolved each week with everyone on the design team, including the owner, the architect, even the manufacturer, and the GC. This coordination process is repeated then until there are no more pending conflicts, and that's when we say that the model is clash-free. Once the coordination then is completed, and we are completely clash-free, we can say that we are able to sign off and the team is ready to develop the coordinated MEP layout drawings and the final fabrication installation per those drawings. So what are some key lessons learned? Well, the secret sauce behind any successful project comes down to one simple word: communication. Communication can make or break any project. There is a need to make and create a collaborative, transparent culture where all parties have an active role throughout the design, the planning, and the construction of the building. It is also essential to bring everyone to the table early in the design stage, preferably, as we said, during the schematic or preliminary design phases, which enables to really create the best value for mass timber projects. And of course, we need to make sure that the information that we are sharing is accurate and it's shared in a timely manner throughout the process among all team members. We need to really break any silos of information and openly share and discuss any information related to the building. This is what truly makes a mass timber building successful. For me, it's very exciting where this digitalization of the industry is taking us, and the opportunity for collaboration and integration that it's enabling. And with that, I would love to open it up for some questions from the audience.
Well, thank you so much for that presentation. I'll just remind everyone watching in, feel free to leave some questions in the Q&A box. Got one here which has got a few upvotes, Maria, and from an anonymous attendee. And he or she asks, how do you get different teams to share IP when using a shared BIM model?
Well, I think that it's very important to get everyone on the same page, right? I think if we get everyone on the same room at the beginning of the project and we make sure that everyone understands that, you know, in order for this project to be successful, we need to be able to share that information. I think everyone, at least with the projects that I've been involved, I think everyone understands of, the responsibility, and everyone understands that IP is also very important, and there is a sort of contract unspoken for that everyone will be, mindful of that IP.
Yeah. And do you think just on that, trust is, I guess with traditional construction, trust is important, but maybe it's even more important with mass timber projects? Like in Australia, we've seen that trust being very important to project teams, and you can bring that trust from one project onto the next, which is pretty related to what you were just saying.
Yeah, absolutely. I think that it's important for any project, but I think it's particularly important to have trust in mass timber projects, just because it's a technology that is relatively new for most countries. And so I understand that there might be some, feeling, oh, well, what if someone uses this information for another project? But the fact is that, we're not really reinventing the wheel in most cases, right? And this information really helps the project and might even help the industry move forward. And then give us the opportunity to have even more projects. So I think that there needs to be trust among all the project stakeholders. And of course, that trust needs to be gained as well. But I think that that's something that once you get a team together and everyone is committed and engaged in the process, I think that is very useful.
There's another question here around Autodesk 360, which I think a lot of people have heard of as a shared BIM platform. Are there any other platforms? And maybe an add-on to that is, what do you prefer?
Yeah, so Autodesk BIM 360 Design is one of the most well-known, most used platforms for collaboration, and allows us to basically have a whole team working on the same model at the same time together, no matter where in the world they are. I am not aware of any other platforms that allow us to model simultaneously at the same time besides BIM 360 Design. Of course, there are other type of platforms that allows us to share information. For example, BIM 360 Docs would be very comparable to Procore. So there are other type of platforms that allows us to share information, but not collaborate simultaneously in one Revit model.
Great. And there's two questions that have come around the idea of, or the question around IP. So if you got a whole project team working on a centralized model, who owns that?
That's a great question. So typically, the person that owns the model is the person that creates the model. So for example, if we have the architecture firm creating the architectural model, the structural firm or engineering firm building that structural model, each of these people are going to be the ones adapting their models. Of course, looking at what the other models are and other participants and team members are doing, but their model is their model. Now, the question gets a little trickier when firms use a third-party modeling team. For example, Via Technic, right? Via Technic, we provide services and we do model development. In those cases, the owner of the model will still be the design firm, because after we typically take the design drawings, we build a model, but then once the model is finished, we have a review with the architect or the designer, and then the architect or designer sign offs on that model. And that sign off process basically puts the IP back into the architect. So even though we created the model, we gave that IP back to the owner of the design, which is the architect. The same thing happens when we're doing modeling for subcontractors. In that case, same thing. Let's take, for example, mechanical systems. We would create the mechanical model for that project. We will generate that model. We will share it with the mechanical subcontractor. They will say everything looks good. We will sign off, and now the model belongs to them.
And is this common, having a specialized BIM modeler who's centralized like you're doing at Via Technic? Because it's something we hear on a lot of projects where you've got repetition of model building between 5 parties. So do you think, where's it going in future to, I guess, minimize that repetitious work that might not be so necessary?
So I think your question has maybe two parts to it. I think that it is right now common to have a third-party company to do these models, just because some firms are not there yet when it comes to BIM adoption, right? And from our perspective, we can provide a more general view and some key knowledge related to BIM development and BIM application. So yes, currently that is something that a lot of firms that have not developed their BIM services or their BIM technology fully are going towards. However, we are seeing that the construction industry is slowly but surely going to more BIM applications and slowly going into 100% of adoption of BIM for all projects. So I think that will slowly be changing, and our role there will be to provide more consulting services through for example, the creation of standards, or more like helping manage the process instead of developing the models itself. And so I do see that could be a way that it could move forward. And then the second part of your question was, I believe, can you repeat that?
It was avoiding the repetitious nature of building model after model, and where's it going in future? Will the centralized modeler build it, and then everyone will just tap into that maybe?
Yeah, and in regards to repetition, there are some technologies out there currently, for example, Dynamo, that are allowing us to really make some of these repetitive tasks. It could be modeling, or it could be 2D creation, that can really be automized very easily through the creation of scripts in Dynamo that can work together with, for example, Revit, which is one of the main softwares that, at least in the US, I know that it varies a little bit in different regions of the world, but Revit, at least here in the US, is one of the main softwares that we are using for modeling development.
Got a question here from Ethan Jones. So when looking at a national top-down BIM mandate, such as the UK, do you think this is the way to proceed for countries like Australia and the US in the future? Or is the way that we're handling it in Australia, which is bottom-up, led by clients, state governments, government departments, etc., the better way to go?
I absolutely believe that with a national mandate, it would be the way to go. I do know of another country, Spain, that has implemented BIM for now, at least for all governmental buildings. And to be honest, I think that we need to really leverage the power of technology and help us be more efficient. As I mentioned, the construction industry is one of the only industries that is kind of lagging in regards to productivity. So why not use technology to help us be more efficient, help us be more productive, and help us avoid issues then when we reach the construction site?
Absolutely. And there's another question here from Ernesto Matarazzo. Whose responsibility is it to come up with a BIM execution plan? And is there a singular document across all stakeholders for the project?
Yes, that's a great question. Typically, the GC, or the general contractor, is the one that develops the BIM execution plan. Now, depending on how the GC works, for example, sometimes they do not create the BIM execution plan, and they hire companies like us that are going to be managing the BIM coordination process. And part of that scope is to also create that BIM execution plan. So there should be only one BIM execution plan, and it's typically shared at the beginning of coordination. So let's put an example of X project. We would start the project with a kickoff meeting. During that kickoff meeting, everyone on the project will receive a copy of that BIM execution plan, and we will read it through page by page, making sure that everyone understands what's at stake, what they need to do, when they need to do, and how they need to do it. I always say that the BIM execution plan is kind of like the set of rules that we're playing by during the coordination process. If you want to play in this game, you need to make sure that you fulfill these requirements, you meet the deadlines that we establish. You, for example, as easy as naming the files the right way in order to make sure that the process runs smooth and we avoid delays.
Yeah, fantastic. I've got a question here. What is the future of BIM in design construction? Do you think you'll see further integration with AR and or other interesting technologies that complement BIM? I'll throw in there, chain of custody, and you've got a background in computational design, maybe throwing in a bit of that there for generative design or anything like that as well.
Yes, absolutely. I truly believe in the disruption of the construction industry through technology. I do believe, and I've seen it over the years, that all these different innovative technologies, and you mentioned generative design is one of them, have been amazingly changed the construction industry so far. We're now able to show an owner or a tenant of a building and walk them through a building before we even break ground, through the use of VR goggles and a model, right? We are able to, for example, if we're doing, and this is an example of our previous work, we did the BIM model for a hospital, and we put the nurses and the physicians in the VR goggles, and we allowed them to experience the patient rooms in the model. And so they were able to touch and grab things in the room and make sure that they felt comfortable working in that situation with the proper equipment. Everything was modeled exactly per the specifications, the beds, everything. So they could really feel the way that they would feel and work in that patient room. So yes, I think that this is definitely the future of construction. There is still much more that we need to leverage, but yes, definitely the future.
It might be worth elaborating a little bit on that concept of generative design, because in theory it sounds amazing, and understanding the practical application of it going forward, particularly with timber design and standardized construction and everything like that.
Yeah, so for example, one of the projects that we did this year was with the Quebec Wood Expo Bureau. And what we did, they have this prefab modular systems that they can ship to places that have been hit by hurricanes or earthquakes. And their plan as an organization was to help build hospitals in the US, in Canada, for relief for this whole situation with the COVID-19 pandemic. What we did for them and how we helped them was to basically generate a generative design tool that allowed them to visualize how that the placement of those modules would look like in the parking lot of a hospital. And very easily they could know how many pods for nurses they needed, how many pods for patients they needed, how many pods for registration and kind of signing in to the hospital they needed. So generative design is a great tool that allows us to generate all these different interactions of design and try options, hundreds, thousands of options in only a matter of minutes without having to do anything rather than just a click of a button. What we typically do is we generate a model, and then we tell the computer, all right, our constraints are the modules need to be, 2 meters, 3 meters apart from each other. There need to be this many nurses for this many patients. And then with that information, the computer calculates all the different interactions and allows us and basically produces and exports a series of varieties of accommodations that then the design team can evaluate and design upon.
Absolutely, and you can change the goals of what the client's after, and not too far away from that, you might have engineering. From an engineering point of view, the computation side of things with Grasshopper and Karamba. Are you working in these platforms as well? And can they link up to modeling to, I guess, save all the manual way of doing computations and let the computer do a lot of the heavy lifting there?
Yes, absolutely. And we've seen a lot of use in Grasshopper. This project with the Quebec Wood Expo Bureau was done in Grasshopper, but we've also seen it, for example, for facades. Very simple work when, we need to evaluate different options and very complex facade systems. It allows us to, make sure that the design is optimized, and we give different options to the designer, and then they can evaluate those options.
Fantastic. Okay, so we're going to go with the last question I've got here, and that's David Mail, and he asks, what's the least expensive software platform for BIM or Federation tools and BIM design and construction from concept through to completion? And is there any open source options available?
That I know of, I don't believe there are any fully function open source software that allows us to to generate all this information and all this documentation, unfortunately. Currently, what we use here in the US is 100%, 99% Revit, Autodesk Revit. We also use other Autodesk platforms. And the reason why we use Autodesk is because the industry is requesting Autodesk. But for example, I do know that in Europe, there is a lot of use of ArchiCAD, which can be a very comparable software. I do think that in terms of the ability to collaborate, and because of all the additional platforms that we are able to leverage with Autodesk and with the cloud mostly, that's one of the main reasons why we always see, you know, a focus on Autodesk right now.
Well, thank you so much for coming on the webinar today, Maria. That's fantastic. What you're doing in the US with BIM Technique is really inspirational for us here in Australia, and I'm sure there's a gap here at the moment for any entrepreneurs and entrepreneurial-minded people listening right now to do the similar work here if BIM Technique is interested also. So thank you so much.
Yeah, no, it was a pleasure as always, Adam. Thank you so much for the invitation. And thank you so much, everyone, for listening in. Hope it was helpful. And yeah, looking forward to connecting.
Yep. And feel free, everyone listening right now, to show a bit of appreciation in the chat, and I'll share it with Maria after. For obviously, we can't have 150 or 100, 200 people applauding on Zoom. So thank you.
Perfect. Thank you so much, everyone. Have a good day.
Okay, so just before everyone goes, just a reminder of the Wood Solutions Timber Talks podcast. Maria was actually one of the most recent guests. So if you're really interested in all the conversation today, feel free to tune in there on iTunes, Spotify, and also YouTube as well. Other guests include Carla Fraser, Michael Marks, who started Katera and ex-CEO of Tesla, and a few people local to Australia, Davina Rooney from Green Building Council, Ken Morrison, and James Fitzpatrick. On YouTube, we've also got some really great videos which have been put together by a colleague of mine, Lawrence Ritchie. These are really incredible if you want to learn how things are made in behind the scenes. It is great to go to a factory and see how it's made, but in my opinion, watching this video is equally, if not better, to actually learn and understand how it's all put together. So go and check it out on YouTube. And as I said at the start, so our CPD forms will be sent out in the next 3 days. Please be patient. If it's, I'll try and avoid emailing us too early because they come in, they flood our inboxes as well, but it will come out at some stage. So for next week's webinar on the 1st of December, already December, crazy, we're going to have a topic on timber finishes for exterior applications. So I really look forward to seeing everybody at next week's webinar. Thank you very much, everyone. Have a great day, and we'll look forward to next week.